So we've been learning about SI unit prefixes and conversions, and I want to just go over a few ways to tackle these type of problems since in chemistry we're going to be working with a lot of really big numbers and a lot of small numbers. So we want to be able to convert between these different units. So the first thing I want to bring your attention to are just the SI units in general here. So we have the meter if we're talking about some type of length. We have the gram if we're talking about mass, and then we have the liter if we're talking about volume. So that's going to be our unit in the middle here that has no prefix on it. And the first thing I would do is just familiarize yourself with what prefixes are considered very big and what prefixes are considered very small. If you know that, it's a good way to help you check yourself as you go along. So everything on the left, all of these prefixes, so we have kilo, mega, giga, tera, all of those are going to be really, really big units. And then on the right, we have deci, centi, milli, micro, nano, and pico. All of those are going to be very small. So one way I like to think about it in my mind is, well, if I have one of these big boxes, so if this is my big unit, it takes a lot of the smaller units to fit into one of that big unit. Okay, so again, if I have one of the big unit, I have a lot of these little small boxes or a lot of the smaller unit to fit into it. Another way to think about that is in terms of money. If I have one $100 bill, well, if I have a smaller unit, a $1 bill, I have a lot of those dollar bills to equal that $100 bill. Okay, so when we're converting between units, I want you to keep this in mind. Think about anytime I have a smaller unit, I should always have a very large number in front of it because I need many of those smaller units to equal one of the bigger unit. It's a good way to always check yourself. Again, the bigger number out in front should always be next to the smaller unit. Okay, so keep that in mind. I would write it down and star that one. All right, so there are a few different methods to convert between these units, and you are welcome to use whichever one you like, whichever one works best for you. But I want you to keep in mind that there are many different ways to solve the same problem. So I'm going to show you a few ways, and you pick out the one that feels best for you. So here are a few different methods to convert between units. The very first one is simply moving the decimal place. Okay, one thing to keep in mind is that this chart that I have shown at the top, this will not be given to you. So you're going to have to come up with this on your own if you want to move the decimal. But keep in mind that you don't have to know every single unit. So for example, I don't have 10 to the 1 or 10 to the 2 written in here, but if I just put a line there as a place mark and I only put in the units that I actually need to know, it's a placeholder and I can still use this to move the decimal place. Okay, so keep in mind that you do have to come up with this on your own. All right, so let's look at an example of moving the decimal place. I have 1.67 kilometers. Okay, I have meters, I have kilo as my prefix out in front, and I want to convert this to meters. Okay, so if I go back up to my chart, okay, I'm starting at kilo and I'm going to meter, so that's just my unit, right? I don't have any prefix out in front. So if I start here, I'm going to move my decimal 1, 2, 3 places, and I'm moving it to the right. The nice thing is once you have this line, it tells you which direction to move your decimal place. So again, we have 1, 2, 3 units, and I'm moving it to the right. So I'm going to go back down here and do the same. I'm going to move it 1, 2, 3 units, so my decimal will now be here. Okay, so since I don't have any number there, I have to add in a 0. Okay, so my final answer for this would be 1,670 meters, right? Another thing I would keep in mind is significant figures. I start with 3 significant figures. I should also end with 3 significant figures. Remember that the 0 at the end does not count. Okay, so I could write it like this because I have 3 significant figures. Let's make sure we show that that's a comma. All right, or I could put it into scientific notation. So I could write 1.67 times 10 to the 3 meters. Doesn't matter, either way is fine. Okay, let's look at one more. So in this case, I'm starting with centi. Okay, so I have centi, and I'm converting to megameters. Okay, let's do the exact same thing and figure out how many times we have to move the decimal place. I'm going to go back up. I'm going to start at centi is here. Okay, so I have centi here, and I have mega here. Let's see how many times we have to move. So 1, 2, 3, 4, 5, 6, 7, 8 times, right? So I move from the right to the left. I'm also going to do the same here. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, and then I need to fill in zeros here. Okay, so one thing you may want to keep in mind is that if I use this method where I'm moving the decimal place, I may have to keep track of quite a few zeros, right? So we should have 7 zeros out front. 1, 2, 3, 4, 5, 6, 7, and 7, 2. So again, we want to check our significant figures. Remember that the zeros out front, leading zeros don't count because they're in front of the first non-zero number. So only the 7 and the 2 count. I kept my number of significant figures. So I could write it this way, okay? I could also put it into scientific notation. So I could write 7.2 times 10 to the negative 8 megameters, right? And let's also double check. Remember that we said from up top, we always want to have the bigger number associated with the smaller unit, okay? Let's go back down. We have the smaller unit here is centi. 7.2 is way bigger than 7.2 times 10 to the negative 8. It's a good way to check yourself. Let's also check the one that we did previously. Okay, we have this bigger number here associated with the smaller unit. I need a lot more meters to equal 1 kilometer, right? So that is the first way. The advantage is all you have to do is move the decimal. I think the downside is you can run into having to keep track of a lot of zeros. But again, it's up to you. Let's look at a different method for this. Okay, so we could also set it up as a conversion factor problem. One thing to keep in mind with this method is it may require more than one step, but that's okay. It makes it a little bit easier if we break it into two sides. So here's what I'm talking about. We know our conversion's going from whatever unit it is to the larger units, so we're going to count that as one side. And then we know conversion's going from the unit to the smaller units. All right, so we're going to split those into two parts. We'll see how that works out. Okay. One thing I like to do before every problem is organize it. Now, if I have a problem with just one step, it doesn't seem too hard, but once I start running into multiple steps, I highly recommend setting up your problem. I'll always give you the benefit of a doubt if you take the time to organize the information you're given. So have is what we're starting with. We have 7.2 centimeters, okay? And our question is asking, well, how many megameters? So it's the exact same problem, but we're going to show that we can do this in multiple ways, all right? Notice that if we're going from, again, centi to mega, we're going through the unit. So we're going to split this into two problems. I'm going to figure out the conversion from centi to just meters itself. And then I'm going to break that up and go from units to megameters. That way I have smaller pieces to digest, okay? Now the first thing I want to figure out is how many centimeters I have in a meter. Because centi is a smaller unit, I should have a lot of those to equal 1 meter. Okay, if I go back up, I see that I have 2 places that I moved. So each one of those is going to count as a 10. So I'm going to have 100. So I have 100, or 10 to the 2 centimeters in every 1 meter. Okay, so I'm going to write 10 to the 2 under here. Doesn't matter which way you write it. All right, The next thing I want to figure out is, well, how many meters I have in a megameter, right? We're going through the center. So if I start at just our unit meters, I have 1, 2, 3, 4, 5, 6. So that tells me I have 10 to the 6 meters in every megameter. Okay, so I have 10 to the 6 meters for every 1 megameter. Okay, for both of these, I would check to make sure that bigger number out front is associated with the smaller unit. Centi is smaller, I have a bigger number, 100. Meter is smaller than megameter, I have a big number out front. Okay, so I have all of the information I need. I like to do a roadmap. So it tells me just the units I'm converting between. So I'm going to start with what I have always, centimeters, and from my get there I can go to meters, and then from meters I can go to megameters. So this is the two-step process. Okay, once I have my roadmap, I'm going to just follow it. So I have 7.2 centimeters. Okay, I want to multiply it by some conversion factor to make things cross-cancel. Okay, so remember that these can always be written as fractions because they are conversion factors. Since I have centimeters that I'm starting with, I want centimeters on the bottom to make it cross-cancel. So I have 10 to the 2 centimeters. Okay, and that is for every 1 meter. Right? Follow my roadmap. Now I'm going to go to megameters. If I look at what I cross-canceled, I already got rid of centimeters. I'm currently in meters. I need meters on the bottom to make it cross-cancel. So I have, according to my get there, my conversion factors, I have 10 to the 6 meters for every 1 megameter. Okay? And I can always simplify problems like this. Okay? If I'm multiplying by 10 to whatever number it is, I don't even need to use a calculator, right? If I combine these two on the bottom, I have 10 to the 2 times 10 to the 6. When I'm multiplying exponents, I just add them. So this is 10 to the 8. Okay? One thing to keep in mind is that we are dividing by 10 to the 8. So my final answer is going to be 7.2 times 10 to the negative 8 megameters because I am dividing by 10 to the 8. Okay, if we go back up, see that we got the exact same answer. Okay, we just set it up in a slightly different way, right? So again, this is requiring more than one step, but it breaks it into more manageable pieces, right? One other thing we could do is we could go ahead and do this all in one step, figuring out the conversion factor. We can also do that. Same thing, I have 7.2 centimeters. I want to figure out how many megameters that is. Okay, and the big difference is we're going to use exponents in this case. So I like to start with the bigger on top. I'm just going to write what mega is. Okay, mega is 10 to the 6. Okay, and I have centi, which is 10 to the negative 2. So it's very important to also memorize those exponents because they will help you. If I want to do this in one step and figure out the conversion factor, I'm always going to take the big exponent and subtract the small exponent. Okay, so I have 6 and I'm going to subtract negative 2, right? Remember that negative and negative makes a positive, so this will be 8. Okay, this is the number that I need. That tells me what the exponent is. So it's always going to start with the bigger unit. So 1 of the bigger unit, so our bigger unit is mega, will always start with the bigger unit, will equal 10 to the, what we just subtracted tells us the exponent, so 10 to the 8 of the smaller unit. Okay, so again, we want to double check ourselves to make sure this big number is always with the smaller unit. Okay, now I have a direct conversion to go from centimeters to megameters. Let's see how we set that up. I'm going to start with 7.2 centimeters again. Since I start with centimeters, I want centimeters on the bottom to make it cross cancel. I have 10 to the 8 centimeters for every 1 megameter. So our centimeters will cross cancel. I'm left with megameters. Since I am dividing by 10 to the 8, it's the same as saying 10 to the 0 minus 10 to the 8. Okay, so 8 or 0 minus 8. So that's going to give me 7.2 times 10 to the negative 8 megameters. Notice that we get the exact same answer, we just used a different way to do it. So especially since we're going to be working with volume in chemistry, something we're going to see a lot is having units cubed. All right, that's what we're going to see more commonly, and sometimes we'll see units squared. I want you to just stop yourself when you see these types of problems, because a common mistake is just keeping the same conversion factor. Okay, I want you to keep in mind that you have to get the correct conversion factor first before you can proceed with the problem. We can't just move the decimal place, because now we have this cubed here. So let's look at an example. What we have is 1.67 kilometers cubed. So this is units of volume since it's cubed. And what we want are meters cubed. Okay, so the very first thing we want to do is we want to figure out the conversion factor between just kilometers and meters. Nothing else first. Okay, so let's go back up to the top. If we are going to kilo, we're starting with our unit. We have 10 to the 1, 2, 3. Okay, so this tells me that for every 1 kilometer, the bigger unit, I have 10 to the 3 meters. Okay, so one thing I want you to keep in mind that's really important is meters cubed are not the same as just meters. So I can't just directly use this conversion factor. I need to actually get meters cubed first. So I'm going to rewrite this conversion factor. And the key that I need to make sure I do is I need to cube both sides. So I'm going to cube this and cube this whole thing. All right. What we want to do is cube not only the number out front, but the unit. That's how we get to the units cubed. So 1 cubed is just 1 times 1 times 1. So I get 1 kilometer cubed. And then 10 to the 3 cubed, now we can multiply those. I get 10 to the 9 meters cubed. Okay, so now I have a new conversion factor to use. All right, and I have a direct conversion. So I can go ahead and plug in now. I have 1.67 kilometers cubed. Okay, since I start with kilometers cubed, I want to put that unit on the bottom. So for every 1 kilometer cubed, okay, I have 10 to the 9 meters cubed. Okay, we get rid of the kilometers cubed. I'm left with the units I want, which are meters cubed. I don't even need a calculator for this because I'm multiplying straight across. So I have 1.67 times 10 to the 9. That is your answer. 1.67 times 10 to the 9 meters cubed. All right, and it makes sense because I'm going from kilometers, a really big unit, to meters cubed. All right, so kilometers cubed to meters cubed, I'm going to a smaller unit. This number out front should be really big. Okay, so 1.67 times 10 to the 9 meters cubed. Right? So I like to actually rewrite the conversion and go from there. One other way to do this is to start off with the original conversion factor here. So I'm going to put 1 kilometer on the bottom, and I have 10 to the 3 meters on top. Notice that these can't cross cancel yet, but if I want to, I can cube it actually in the problem itself, right? This is another way to do it. I like to go ahead and write out the conversion factor or rewrite it, but it's up to you. But it will get you to the same answer just as long as you cube the numbers. So I still get 1.67 times 10 to the 9 meters cubed, right? So lots of different ways to solve the same problem. You're welcome to use whichever one works best for you.